So I want to talk briefly a little bit about my history and what I'm going to be talking about. So I've been working with Python back since 2001. I realized I was talking to some young students earlier that I think they may have been before they were born. But yeah, so I've been around for a long time. Initially, I was just doing scripting and utilities in the place I was working. And my first full-time gig was actually when I was in London working for Royal Bank of Scotland doing their CMS using Zope. Does anyone remember Zope? A few people. Okay. So I've had Python on and off since then, and I ended up having some absolutely great testing teachers. I'd just like to shout them out. I had John O'Lang, who is from Australia, and Michael Hudson-Doyle, who originally from the UK, now lives in Wellington. They are both awesome teachers and pretty much taught me everything that I learned about testing in Python. And I joined Stacklet about just over 3 years ago now, doing a lot of serverless Python, AWS. And what I want to talk about a little bit is briefly the differences about unit test and pytest, and following my journey from ick to awesome, because I was not a fan when it was thrust upon me. So unit test, I would consider this as like the workhorse of the Python testing library. It is part of the standard library. It has been around for years, and it was originally based on JUnit. And since it came from a Java-based origin, everything was class-based. Everything was a class, you had lots of methods, and it was just how you did things. So in order to end up creating your tests, you would end up inheriting from the test case base class. Now, I think I've just sort of leapt forwards a little bit. I'm making some blind assumptions here that everyone is testing, loves testing, and is writing tests now. Can we just have a quick show of hands? How many people actively write unit tests as part of their day-to-day job? Good. Talking to the right audience. One of the things that got beaten into me in the early days from Jono and Michael was that if it's not tested, it's broken. And I've been involved in programming for a very long time, and I like to think I'm quite good at it, except I proved to myself over and over again by writing tests that my code is broken. So I'm very much in favor of testing. You should test everything. So now with that assumption, moving forward, it's just like, I'm assuming you also want to agree that we should be testing everything. And we'll talk a bit more about that. So with your unit test, all of your test cases are going to be in a method. It starts with test underscore something. And the base test case manages a lot of internal state with methods. You have a setup test, you have teardown that allows you to run code before and after every test case that you're running. And then if you've got collections of things you need to execute that you want to group together, you'll have a setup class and a teardown class, which is responsible for the common setup things that you're going to want to use. Now, the other interesting thing about this is all of your assertions are method calls. So you have the simple ones where you want to test for equality or non-equality, or test the things that are true or false. But then you get to all of the other things that you want to test. Is it this type? Is it this type of object? Is it in this collection? And there are a lot of different methods that you need to end up remembering. So that's the basis of unit tests. And so pytest is, I like to think, the new hotness. And I always wanted one of these as a child. Never got one, and to me, they very much, so this is a plasma ball for those that don't recognize it. It was very hot in the late 80s, early 90s when I was a child, and only the really fancy people had them. So pytest grew out of the PyPy project originally. You can go find it at pytest.org. It is not part of the standard library, but it's very easy to include to your project and start using. You can just pip install pytest. You start running your tests with pytest, and that's it. You're using it. And that was pretty much my introduction to it. The setup for the project was done. We had our little command runner that would run the tests, it was running them all with pytest, and I was writing unit tests because that's what I knew, that's what I was familiar with, that's what I thought was good. And the good thing about pytest, one of the things with its test discovery, is that it was quite happy to find all of your unit tests and just run them, which means I didn't need to change. And I learned something in the last talk from Grant, which is the fact that the __ init isn't needed anymore. I didn't realize that, so that's something to go and read up on and see if I can remove some redundant files. But pytest is very good at discovering it. And the other thing about pytest is that it doesn't require classes, you can just have test functions. It's the lower barrier to entry. It's very simple to write just a test function to test something rather than having to write a class and a method and moving forwards. It's got a very rich community with a lot of plugins. It can do many things. So why didn't I like it? For me, it was very much a gut reaction. It was visceral, and it stemmed from the Zen of Python. How many people here have not come across the Zen of Python? Liar. The Zen of Python is very good. Now, I'm going to say liar. For any recording, this is someone that I knew that I was accusing, not some random. But the Zen of Python is built into every interpreter. You can import it, you can read it. And this is one thing that was very important to me, is that explicit is better than implicit. And I just felt like pytest was too magical. And that was enough to make me want to go, yeah, nah. And so I didn't want to do it. So what was this implicit magic that it had? There is a file that you can have called conftest.py, and it's treated differently to all of the rest of your test files. It can be where you go and put fixtures that you would create that would then be available for you to use. There are a whole pile of automatic fixtures that come with pytest that you can just use. And the biggest one, the biggest ick that really made me squicky was the way in which you used a fixture was you just called your argument to your test to be the same name as the fixture that you're going to use. And then magically it would be found and used. And that just felt weird. And I didn't like it. And I had that gut reaction. For a while, I resisted. So a quick delude as to what is a fixture. So a fixture in pytest is effectively a piece of code that performs an action and returns a value for you to use. I previously used the term fixture when I was doing a lot of unit test stuff, which to be a collection of often external functions you would call to create a whole pile of stuff for you to test against. And that was my mental model of what a fixture was. But in the pytest world, it allows you to effectively do that as still an external function, but the way in which you use it and call it changes. So one of the things you can do with a fixture is to use the yield statement. The yield statement will turn your function into a generator, which means that you can have your setup and teardown code for this piece of information that you're setting up in one place. If you were doing using unit test, what you would have is you'd have some code in your setup, and the old bad way was you'd have the teardown and the teardown function. The problem with doing that is if you had failures in your setup, you had a multi-stage setup function. If setup failed, it wouldn't run teardown. And so that became a problem that when things went wrong, as they frequently did when you're writing code, you would leave mess lying around. And so what unit test started doing is they started creating, they added an add cleanup method that you'd start calling, and that became awesome. So I started using that everywhere. In the setup, you'd do a bit of setup, and then you say add cleanup to clean this up, and then you do your next bit of setup and add your next cleanup, and that was just a way to make sure that when your tests failed, everything cleaned up. What pytest does with a fixture, and particularly with a generator, it allows you to keep your setup and teardown in the same function. So you can set some stuff up, yield the result, And then when the fixture is being torn down, it runs the rest of the code. So it just uses the generator to basically yield a single value. But it is really quite cool. Almost feel like this should be just before that other slide. So why did I change my opinion from being PyTest is ick to actually it's kind of cool? And I think I went back to the Zen of Python because I had to analyze why did I change? Because I still feel like explicit is better than implicit. But there are some other then overriding things. And it's like, well, okay, beautiful is better than ugly. And I think code can be beautiful and should be written in a way that feels beautiful. Simple is better than complex. A lot of the way in which you would declare your fixtures and use the code felt simpler and easier to explain using PyTest. Again, sparse is better than dense. Using fixtures well allows you to separate things out, have smaller functions, smaller things that are well defined, rather than large setup methods in your classes that you're going to end up using. And one of the big things that always comes back to me is readability counts. You're going to read your code way, way more than you're going to write it. And coming back and being able to easily read and understand your code is essential. And one of the early bits of advice that I was given from these two people earlier is that every test you write should be obviously correct. If you are basically looking at your test, you're bringing it up, if you can't tell that it's correct, then it's really awkward. You need to be able to look at a test and understand that what you're looking at is actually doing the right thing. So how do you start using PyTest in a project? The first couple of bits were set up for me, but effectively you just add PyTest as one of the project dependencies. You start running your test suite with PyTest. It has very good test discovery. The chances are you won't have to do anything for it to find your tests. Our project tends to put our tests in a tests folder at the top level. So we have our source code starting with Stacklet, obviously, for us. And then we'd have the tests in a separate folder, and PyTest is very good at just finding them and running them. The next thing you want to do is move from using the built-in assert functions of unittest to just the base assert level. So normally a simple assert statement in Python where something fails, it will raise an assertion error. And the type of error message you would get out of the interpreter would basically say, assertion error X is not true, which isn't very useful in a unit test. But what PyTest does is it actually hooks into the base level of assert function and will actually give you proper stack traces and diffs and useful things that I was used to getting out of the unit test methods. And it just does that by hooking into assert. So that was beautiful. It also meant I didn't have to think about which method to call. Once you've done that, you want to move your common setup code that you're using in your classes, moving them into fixtures instead of your setup functions. The other thing that did catch me out once is ensure that your classes that you're using are now called test something. The unit test discovery will say, I will find anything that inherits from unit test case. So that's fine. But if you stop inheriting from unit test case, then the PyTest discovery doesn't find it anymore. So as long as you call it test something, the PyTest discovery will pick it up again. And then stop inheriting from unit test case. And if you've done everything right, your tests keep working. And now you're using PyTest. So the key takeaway that I had from that change was that your configuration reuse moves from a hierarchy of classes into a collection of common fixtures. So you're effectively moving from inheritance to composition. And people can argue which one's better. Some of the newer languages like Go don't have inheritance and everything is composition. I actually quite like composition now, and I think it's a better way, particularly with a lot of the way that the fixtures end up getting used. The assert lines become easier to read because it's becomes a simple statement. And I also use a nice editor that highlights reserved words for me, and the assert line is a different color to the others. So little things. You don't have to remember which weird method to use, that you need to know that some of the collection ones are different from the others. But also cleanup code became easier to manage because of the way in which your fixtures can yield the result and then clean up afterwards. So now we're going to walk through a bucket load of examples. So here's some code. It is not entirely, it is all live code, old code that used to be it. It's cleaned up slightly. So this was our database test case. Now you can argue, should you or shouldn't you use a real database in your unit tests? Different questions. We were using Postgres, and we wanted to test that our actual Postgres integration was working fully. So we would be running Postgres inside a Docker container alongside our tests. And so we would have an environment variable basically telling us when that has been set up from the thing actually running our tests. So unit test has a nice way to skip a whole class to say, well, so our thing here was, if you haven't set the environment variable, don't bother running any of these tests because they're not going to work. We had some class methods set up that we would do to create our database abstraction. Early code we had an entire abstraction of our database because we were using DynamoDB, we had things into Elasticache, and we had Postgres, and it was easier to do it into this model. That's all gone now, but it's interesting. That abstraction was a class level thing. We had an object factory that creates all of our objects. You should have one. I'm not going to talk about it in this particular talk, but having a test factory that creates your entities for your testing is an awesome thing to have. So every time we run the test, we would basically have some simple setup. We would clear out the database, insert some basic stuff, create a database session, and then we had some cleanup methods here to make sure that we closed things and everything was good. So that was our base test case for all of our database test cases. We then had this other one. We had our API was all written in GraphQL, and GraphQL required that database to exist. So clearly our GraphQL test case would inherit from our database test case. It would also create the database schema. And whenever we were trying to do anything with the API, we wanted to make sure we had a few users around. So we created some read-only users and write users. And this, again, became the base test case for all of our GraphQL tests. So then we would have our actual tests would use inheritance. So here's a simple example of our account queries. We would create use our factory to create some accounts. And then we grabbed our pager that was responsible for loading a page of accounts. And then we had a helper method to basically grab those nodes out, and was like, grab all the nodes, the names from that. And we want to assert that the names we get when we say, grab me anything with div in the name, actually gave us the values that we would expect. And that became the basic test case. This should be relatively familiar to anyone writing unit tests. So what changed? So that sort of became a bucket load of little fixtures. So we started off with the base level fixture that we had, which was our relational database. Hence the short name of the fixture. We can still have a method for pytest skipping. So it has a different method to basically skip tests. The interesting thing about this is if you have a test that relies on a fixture that might rely on another fixture, and that fixture gets skipped, then all of your tests get skipped. So when you go to run your test, you see little S's instead of dots. But it's you don't have to do any other magic. You just run your tests and you can see that they're skipped easily. So what we set up here is some environment variables. This is how we ended up passing our data in to say we are pointing to our local, our test Postgres. You can see there that we actually pass the username and password in as the URL because it's on my machine. It's not holding anything. We can just pretend it's a full string to basically connect to our database. And then what we do, and this is, I still have my unit testiness here, because I still use the unit test patch methods and the unit test mock package a lot. So we do still have some things here where I will patch out the environment using the unit test style rather than the pytest. Pytest does have a monkey patch module that will handle environment variables and patching as well. Haven't fully been converted to it yet. It may yet happen. But what this allows us to use is the unit test patch method from the mock package that will effectively give us a context manager that will replace the environment and set it back when we leave the context. So what we do here is once we have created this environment, our upgrade Postgres method was the thing that would do our SQL Alchemy installation or upgrade of all of the tables and schemas. That would all happen there. It would load the initial data, and then we would then yield the result. So inside this with statement, we've now got that environment set. We would then have a next session that was a next fixture was based on that. So you can see that the argument to this function is RDB. This is the magic that happens to say I need this fixture. So what pytest will do, it'll make sure that fixture has run up to the yield statement, and then it will pass the value of the yield forwards. Now, I didn't yield anything. We just, so RDB is none in this example, but it does that setup for us. So what we do here is we say, well, let's just grab a database session. So we actually have, I'm hiding some actual functions here, which actually create the database connection and give us a session factory. So what we're creating here is a session, again, using a context manager, that when we leave this context, we'll close the session and roll back if it needs to. But what we do here is we're actually yielding the object. So we're returning the session object itself as a result of this fixture. Next, I realized, the initial data was actually in the reset DB bit. So this session here, this is the session most people will use because we have a dirty session which doesn't touch the database, just gives you a connection. The actual session we end up using most of the time is the thing that would say, go and reset the database, because often when you're running unit tests, you don't want to rely on any existing data. So one of the things we do in every test case is truncate all the tables. But then if we've truncated all the tables, most places or a lot of places will have that one or two tables that might hold initial config that you need to manage. So we have our, install the initial data method that we have, which is part of the reset DB function. We then have our factory fixture, which will take the session object itself and then create a factory object. This factory object was an idea that I first got exposed to about 16 years ago, where we were creating, you want to be able to create your object with the bare minimum things that you ask for. If you only create the object with the attributes you care about, so back in the previous test, we said create an account. The only thing I gave that account was a name because that's the only thing I cared about. I don't even need to give it any names. If I don't, I can just say create an account and it will create me something valid in the database that is an account. So the idea is that the factory thing here is a class that can create all of our entities with minimal or no actual attributes. But what it does to manage that is it has an internal counter that it increments all the time, which is why we have this nice little comment here. So don't go and create your own factory, use this fixture or inherit from the base class. So we still created, so in our move from unit test to pytest, we had a lot of existing tests and a lot of existing tests that are inherited from our database test case. I didn't want to have to rewrite all of those or edit their inheritance or anything. So we created a base test case that, and this is the complete class, and it's literally just a test base case that has a session object, session attribute, and a factory attribute. And I'll go into the actual base class a wee bit later. So the actual implementation looks almost identical. And for those that remember the previous one, the only line that's changed here is the last one that went from assert equals to a simple assert statement. Is this name list match this other thing over here? And that's it. So that was nice and easy. So the key thing is the asserts are nice, but it's the fixtures that are awesome. Fixtures are what sold me on pytest in a huge way. fixtures, you want to make them small and composable. If a fixture is used multiple times, like for example, our database test case here was using the factory fixture, and our test might use another fixture that will use the factory. When pytest comes to create and manage those fixtures, it will realize that two things need a factory. It will instantiate that factory once and then pass that yielded value through to the places that actually need it. So you don't need to worry about larger fixtures being run multiple times, because pytest will just manage that for you. I'm sure it'll tell you if you have a loop in your inheritance. I don't think we had to worry about that. That does mean that the base fixture can share a lot of code. So the factory is the example of that. And I've already talked through those pieces. So here's another thing, is fixtures can be defined in multiple places. If you define them in your conftest.py, those fixtures are available to any test case in that package or any sub-package. So we have a top level, so we have tests, unit tests, and then we have a conftest.py, and there is our base test cases and our sessions. Then we have sub-packages under that may have their conftest.py. That conftest.py fixtures are only available for that package and not up or across. The other thing is you can define a fixture inside just a test Python function itself. So in your test account.py, you may create a fixture that is only visible to that module, which is convenient sometimes if you have the same name you want to use in multiple modules just to do the local setup. But it also means that you can do things like auto-use a fixture. Auto-use fixture means this fixture will get executed whether or not you ask for it, and it will just happen in the environment which you run. So if you create an auto-use fixture at the base level, it'll always be used. If you do it inside a module, it's only used for the tests or classes inside that module. And if you do it inside a class, it's only used for the tests inside that class. So that can be extremely useful. So if you have an auto-use fixture inside a class, that pretty much operates just like a setup test method from unittest. In fact, I used exactly that in a number of places. So here's a nice little utility class that we wrote, because we started using fixed when we realized how important fixtures were going to be and we were going to use them everywhere. Creating your own simple ways to say, I need that fixture in this test case, which means I need to have an auto-use setup that will brag in that fixture and attach it to my object. We realized we were doing that over and over again. We broke out this test case, this base test class. So this became the base class for all of our fixtures that we use. So if you don't need a database, and you're just using a base level thing, but you do need some other fixtures, you can still use this fixture base class to bring in the fixtures. What it does is it has a dictionary here you define, where you have keys and values, both strings. The key becomes the name of the fixture you're trying to find, and the value is what attribute do we assign it to in the local object, in the local class. So we use this, the magic of the method resolution order, I think that's what the MRO stands for, to basically start at your base class, walk down looking for this attribute. If there are anything there, use the requests fixture, which was one of the built-in ones from pytest, to say, go and grab me that fixture, and if they've asked me to put it into an attribute, assign it to an attribute. So if we think back, because I'm not going to slide back to it, our database test case defined too. It had session to session and factory to factory, which just meant that we would look for the session fixture and assign it to the session variable and manage it that way. So now let's go run through some other little nifty fixtures. So this is a remarkably useful one that we used, which is just set your base logging levels. By default, your logging levels are only going to give you things from warning and above. So we wanted to say, so this is in our base conf test file that gets used automatically. We don't have to specify to use it. So we say, go and get me the root logger and set it to debug, because I want to see everything in my test output. Another one we have, which is very application specific, is we have some application config that we have at a core level, and we just want to initialize it to empty. So we want to always have that set cleanly as well. Another good one that we had was, since we're dealing a lot with our AWS and interactions, we would regularly have active session keys to our AWS stuff. And what we didn't want to do was accidentally spin up lambdas, queues, other things that we were doing in our tests. We didn't want to accidentally spin them up in real life. So we patch out all of those environment variables, anything that would be AWS specific. So we would reset the region and our access key, the secret key, clear out the token. And that config name is just another thing that is not AWS specific, but we do clean out, and we do it for every level. Now, the interesting thing about here is the scope. Your fixtures can have different scopes as well. So a package level scope will get executed as it enters the package and will get torn down at the end of the package. So you can have class level, you can have no scope as the default scope, which is going to be the test scope. But package level ones are good for things like environment variables where you're not needing to worry about them too much, but you do want to clean them out. The other thing we had is, again, dealing with a lot of AWS stuff, is we wanted to mock those out. We don't want to actually talk to real AWS clients. So there is a nice package out there. The Python library for AWS is called Botto, or Botto 3. And there is a Motto package, which is a mock Botto. And it has lots of context managers for basically patching out certain AWS clients for you to use. So what I've got here is just 3 simple examples where we patch out SQS, SSM, and S3. So the queues, our system manager, and the buckets. And what we do is we yield those clients back. So we are inside the context managers that will basically set it up, yield it out. So anytime you're using one of these fixtures, you know you're not going to be talking to a real Amazon client. So an example here is we have a lot of places in our code where we'll be looking for files in an S3 bucket. You need to make sure the bucket exists. So one of the fixtures we would have would basically say, use that previous one that basically mocks out S3, and now go and create me a bucket. And the way in which our code would look for the identification of that bucket was an environment variable, because we're running serverless, so that's how we get our basic information in. So what we do here is we create a bucket and then set the environment variable to the name of the bucket, and then inside that yield patch statement is actually return that name for our code to use. So that's a nice simple way. Another thing we do is we do lots of management with queues, lots of things. We will push messages onto SQS, and we want to make sure that those messages got on, that the shape of the messages that we put onto the queue is what we actually expected to put onto the queue. So again, this here uses the idea of we're going to mock out SQS, we're going to create a queue, and we're going to, the hard bit here is hidden in this class called message iterator. What it does is effectively we'll use the Botto API, load the queue, and ask it for, say, go get me all your messages, and it uses that timeout. So it's going to wait a second to say, is there any messages here? And then it will yield those results. So what we do here is, what we're yielding as a result of this fixture is actually a function. So we're creating a closure in here called get messages. What that's going to do is walk over the iterator to say, the message iterator gives us an iter interpretation, so we can walk it like a list, and grab the body of the message out, load the JSON, and return a list of dictionaries, which is the payloads of all of the messages. So yielding that function means when I have a test case that one's going to deal with these queue messages, it uses this fixture, and whenever it wants to say, well, what are the messages in that queue, it calls the fixture. So just using your brackets to call the function, and then at that stage, it will basically call this closure, call the iterator, what messages are there, JSON decode them, and pull it out. So it allows you to do a lot of work in a small space. So we add back to our GraphQL test case. we created users. We created 3 different ones. So now we actually have 3 simple fixtures to create our different users, whether they're an admin or a viewer or someone that has no permissions. And then we also provide each of those as a single fixture that says, go give me all of those users, and just returns the dictionary. Again, using yield to return the right results so you actually have access to those objects that you have created. Also, the pytest allows you to parameterize. If you've got a lot of small tests, there are a couple of ways you can do it. You might write 10 different small tests that each have 1 line in it. Or another method I've done before is you'll write 1 test. It's like test simple, and it has 10 different calls to the functions to say, is this the right way to do it? pytest gives us a different way to do it, where we can use this parameterized method where you give it the variable names and a list here. So what we're going to do is this will call this method called test chunks. Those attributes, source, size, and expect are the names that are defined in the first piece. A little bit of magic here, but this is where you our trade-off is readability versus implicit magic or clarity. So here, the test chunks is basically each test case is basically saying, call this function of the size with the source, and do we get what we expect? And pretty much all of your IDEs will be able to analyze this and break it out and say, well, actually, we know that there are 4 different tests here, and you can then run them independently in the IDE frequently. And there are many other plugins you can end up using. Here are just a couple that we use. So pytest env can allow you to automatically load .env files from your project home and make them available inside the tests. A lot of projects use this mechanism to unify the environment for the project across all the developers. That can just bring this automatically in for you, so you don't have to manually load it. We use pytest cov to give us additional code coverage. Me and one of the other developers love gamifying our test coverage. We always want to get it as high as we can. And again, when it comes back to that, if it's not tested, it's broken. If you haven't tested all of your lines of code, how do you know that it works? So I try desperately for 100% test coverage. Don't get there, but at least it becomes the target of what you want to aim for. And that, there are many more on the website. And we probably have a little time maybe. All right. Now, I know lunch is going to be very soon, so maybe just 1 or 2. If anyone has questions. If we don't have questions, we've got lunch.
Which mentioned pytest monkey patching.
So the question is around my thoughts on pytest monkey patching. So monkey patch is the name of the fixture. I've actually have started using it in a couple of places because it allows you the ability to delete environment variables, whereas unit test patch object does not. So you can, the convenience there is being able to actually remove them. I monkey patch excessively in many of the tests all over the place, whether we use the unit test mock.patch method or whether I use monkey patch. They're just implementations for replacing something with something else. But I do use it a lot. So my thoughts on it are it's very useful. Whether or not you monkey patch one way or another, I'm fairly light on it. I don't mind what people do, particularly as a code reviewer. I'm not going to care. I'm not going to argue. But the biggest benefit I found from monkey patch recently is it allows you to delete an environment variable where it is not easy to do in the unit test package. Anything else?
Oh, there's one question over there.
So, you commented that it's not tested. It's not working. I have worked on family project where I'm inheriting and project. Well,
yep.
Let's try it. We were in this public bridge. Well, there. Do you have any comment or advice out here, bro? Affects tests to.
Okay, so the question is coming into a project that has not necessarily got test coverage. How would I recommend going and to get more test coverage, hopefully up towards 100%. I don't think 100% is realistic for any real life project. What I would recommend doing is you can actually put inside one of the pytest command line arguments is to fail a test if test coverage falls under a certain percentage. My suggestion would be, first thing, start measuring coverage, and then slowly ratchet it up as you add more test coverage. You can normally get to 30, 40, 50% test coverage very quickly by writing very few tests, because that will exercise quite a few code paths very easily. What I recommend then is you just slowly ratchet it up. What we have is we use the coverage plugin to our GitHub Actions, so that whenever we put up a PR, we will get the coverage report pasted in the comment. But we don't have that. So it tests, what that tests is the percentage of code coverage of your patch and the percentage of code coverage of the project. And it says neither of those should go down. So, but we don't make it binding. It's there just to shame you, right? So it's there just to say, you really should make it better, but we're not going to fail the PR or say it's not mergeable because it's not there. So my first thing is start measuring, ratchet it up slowly. And I think we probably want to go for that. So thank you, everybody.